Good morning, grade 8. Today is the first online class that we have with presentation, with the lesson. Last meeting, we have an activity. We call it Do It Now. But today, we will have the actual discussion, the subject matter. Let me share my screen in a while. Can you see my shared screen now?
It's black.
It's black. How about others?
Can see it.
Okay.
Yeah, we can see it.
Okay. Let's have the laws of motion. This is actually laws of motion by Newton. Okay. What are Newton's law? Okay, what does it really mean? To explain motion. What's in the motion? How can you say that an object is in motion? Okay. Is it
It's
not the
moving.
motion just takes place? Yes, RJ?
When it's moving.
When it's moving. How can you tell that an object is moving?
When it goes from one place to another.
Yes, correct. From this point to the next point, yes, correct. There is motion there. Okay, according to Newton's law, that these motions has forces acting on it. Let's take a look at the forces that actually acts on the moving body. Okay, many things can be explained by the use of actual observations, and some are explained by simple common sense. Many attempts have been done to provide a set of ideas about motion. Galileo Galilei was the first to suggest, this is actually based on the observation of Galileo, suggests that the uniform speed of straight line motion was just as natural as at rest state of motion. So this is also the movement of the heavenly bodies. Okay, without intercepting or without forces acting on it, it will continuously move. Although Galileo did not fully explain motion, he took the first important step by doing so, radically changed our view of motion of objects. Galileo's work profoundly influenced Sir Isaac Newton, the originator of laws of motion. During that time, Sir Isaac Newton is God. Okay, because he actually created explanations about heavenly bodies, about movements of the heavenly bodies, about gravitational pull, and so on. Balanced and unbalanced forces. Okay, forces can be produced or can produce changes in motion. There is a change in motion when. So these are now the criteria to consider when we actually have the change in motion. Number one, an object at rest starts to move. There is a change of motion. Okay. Second, an object in motion changes speed. If it changes its speed, there is a change of motion because there is what? There is a force acting on it to change the speed. The third one is an object in motion changes in direction. If there are some changes in direction, therefore there is also a change in motion. And the fourth one, an object in motion stops. If an object in motion stops, of course, the motion there stops also, or there is a change in motion. The force that is capable of changing the state of motion of an object is called net force. Okay? The word capable is taken into account because while force may be acting on an object, okay, its capability to cause change in state of motion may be balanced or cancelled by another force or forces. Therefore, a change in motion may not be necessarily follow when force is applied, but it follows that the force acts alone. The object that acts on will change its state of motion. So if there are some changes, if there are some forces acting on it, there are some changes also of motion. If there is a force, a net force acting on that certain object moving, there is always a change in motion. Okay? Have you seen force can speed up or slow down a moving object? Accelerating and decelerating. Are you familiar with this? I think we discussed this
Yes.
one in your lower years in grade 7, correct? Accelerating body and decelerating body, correct?
Yes.
It produces an acceleration. Okay, acceleration meaning it speeds up. Deceleration
Faster.
meaning slows down. Okay, since acceleration is a vector quantity, force itself, force is itself a vector quantity. Force has both magnitude and direction because it is a vector quantity. Since several forces can act on an object, the combined effect of these forces or net force will be very interesting to know. The net force is zero when two forces are equal and they act on opposite directions. Okay? Equal. If there is a balanced force, therefore, there is no movement because, again, it is balanced. The force acting on the body and the force that you exerted are actually balanced or same
What's
or
an
equal to
example for that?
zero. Okay, so what is an example for that? When you push the wall, okay, pushing the wall, if there is no force acting in the wall, what do you think will happen to you if you push the wall?
You'll go away from the wall.
Yes, you'll go with the wall, correct? Because there is no force acting on the wall. But the wall in your house or the concrete wall has force on it. So when you push the concrete wall, what will happen?
You'll get pushed
Okay.
backwards.
Huh?
You'll get pushed backwards.
You get pushed backwards? It
The
could be.
wall,
When
the
you push
wall,
a wall, a concrete wall, with your full force, what will happen to you?
Injured.
Injured?
You'll probably fall down.
die.
The answer is, what will happen to you when you push the wall, the
Let
concrete
me
wall?
try it.
Okay. What have you
Happen.
observed? Huh?
Nothing will happen.
Nothing happens because, again, what?
You'll feel the force within your body pushing yourself away from the wall.
Okay. Alright. Because, again, the wall exerts equal energy, equal force towards you. That's the reason behind.
Is it the same if like two people are pulling a pencil?
Yeah. It depends upon the net force acting on it. But if it is equal, there's no movement then.
That's balance force.
Correct. That is actually balanced force. Very good. Okay. If there is a balanced force that's equal to zero, okay, there is no movement then. Because the body is exerting equal force towards your body, the opposite. Okay, the opposite body. Okay. An unbalanced force or net force produces acceleration. Why? Because again, it actually what? Acting on a particular body, which is stronger. The net force there is stronger than the other force. Okay, later on, you will see that the unbalanced force can also cause deformation of an object. The net force may change object size and shape, and this evolves in a change of motion of some parts of an object. So this is the reason why there is motion, because of the unbalanced force. Take note that that Earth rotates rotates in its own axis and revolves around the sun continuously. Okay, this is because of what? The forces acting on it. Okay, once there is an unbalanced force that will act on that certain object, it the motion there will eventually change. But because there is no unbalanced force acting on Earth or Earth's movement, rotation, and revolution, what will happen to Earth? It will continuously move in a uniform motion. That's according to Newton. Isn't it amazing? Isn't it very interesting?
I find it a bit fascinating.
Come again, Travis?
I find it a bit fascinating.
Yes. Actually, I am a fan of Einstein and same with Sir Isaac Newton. Let's move forward. The first law of motion by Newton is the law of inertia. Okay, in physics, inertia also includes the idea that moving objects tend to keep moving. That's inertia. That the moving object tends to keep moving unless there is a force that acting on it. Galileo defined inertia as a tendency of an object to maintain its initial state of motion. Newton related the concept of inertia to mass. Originally, Newton called mass a quantity of matter, but later defined it as a measure of inertia. Okay. From this idea, it can be said that an object that is more massive has more inertia or more resistance to change in motion than a less massive object does. For example, a truck has more inertia than bicycle. You can actually if the truck is moving in a uniform motion or a straight line, you can hardly stop it. Correct? You apply brake, but it takes around seconds or a minute in order for you to stop. But with the bicycle, if you're moving in a straight line direction, in a uniform motion, you can stop it directly. Again, because the truck is heavier than the bicycle. Newton's first law of motion, which is also known as the law of inertia, states that a body at rest remains at rest, and a body already in motion remains in motion with constant velocity in the absence of unbalanced force. Other books stated this law as an object at rest remains at rest. An object in motion remains in motion unless acted by the unbalanced force. If there is no unbalanced force acting on that certain object, it will continuously move in a uniform motion. That's according to the law of inertia. Do you have any questions so far?
No questions, sir.
Okay, you may experience an example of Newton's first law of motion, the inertia when you ride a train. Okay, imagine that you are standing still in a stationary train. Here in our setting, beep bus, you can observe this one. Okay, when I usually ride beep bus, okay, I usually observe people or these people standing in front of me. Okay, once the beep accelerates, what could happen to these people standing? That is actually what? The Newton's first law of motion. It is really intriguing. Why? Their movement are in uniform. Have you seen them standing full?
Yes.
Their movements are in uniform motion. When the bus brakes, they also move towards front, which tend to what? Which transfers now the energy from them towards the front. What is that force that acting on it? And that's the big question there. Correct?
Yes, sir.
Remember that your road also has force. There is no movement of the bus if there is no force on the road. Correct? The force there also includes frictional force. How do these forces act on it? How do these forces also create movement towards the bus? Those are the questions. This is based on the first law of motion by Newton, the law of inertia. Isn't it amazing?
It is.
The train floor accelerates your feet, but your body falls backwards. Why your body is actually, if it accelerates, your body will tend to move backwards. Why? Why? What is that force that tends to pull you backwards? As you hold onto your handle, the force exerted by the train or the handle gives your body forward velocity. So the handle there serves as what? What? Serve as your stopping mechanism, because if there is no handle there, tendency is you will be what? You'll be moving backwards all throughout. Correct, RJ. The object will not change its motion unless the force reacts on it, or the unbalanced force. But the question there is how? How do these forces act on that certain body? Okay, this is based on, again, the first law of motion by Newton. The momentum shoots, yes, correct, Travis. One standing in a car, fast, immediately stop. I guess that's the, yes, correct. Correct, Travis. Very good. On the other hand, when the train suddenly stops, your body will continue to be in motion, so it moves forward until something stops it. Or if you're gonna hold the handle to overcome that force. So here comes the example there. As you can see, there are people standing on the bus. So once it accelerates, tendency is the people standing there will be pulled by that particular force. And once it stops, okay, the people also be pulled towards the opposite end, or it moves forward. Correct. This is why you wear seatbelts. Yes, this is for your protection also. That's the first law of motion by Newton. That's why I'm really into science, because these are my my cup of tea. Okay, these are my expertise, and I really like them. You know, you can just observe them wherever you go. Correct?
Yes.
If you are really observant, then you can observe all of these.
Yeah.
Okay. We have seen from the first law of motion that passengers inside a fast-moving car may get hurt when the vehicle suddenly stops. This is because of their body's tendency to continue moving forward toward the windshield. Okay? Seat belts, just like what RJ told us a while ago via chat box. Okay? Seat belts prevent the passengers from moving in the direction of the motion. To ensure the safety of the passengers, in case their vehicle suddenly stops, there is now a law that requires passengers and drivers to use seat belts. This is for your own protection. Okay, let's move forward. The second law of motion by Newton is the law of acceleration. Okay, the relationship of physical quantities or force, mass, and acceleration are stated in the second law of motion by Newton, which is the law of acceleration. It states that the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the mass of the object. So if you're gonna put it in a symbol or formula, it is acceleration directly proportional to force, and force is inversely proportional to mass. So the equation form, we can state that the second law of motion by Newton is force or net force or external net force, okay, is equal to mass times acceleration. Okay, what really can this suffice us is that this equation will give us an idea that there is a relationship between mass and acceleration. Mass and acceleration. So this is the reason why we can hardly stop, okay, a big cars or a truck van than a bicycle, because there is a relationship between mass and acceleration. Correct? 14. Okay. Why? Okay, again, the relationship of physical quantities, force and mass and acceleration are stated in Newton's second law of motion, or the law of acceleration. It states that acceleration of an object is directly proportional to the net force acting on an object and inversely proportional to the mass of an object. Okay, this is the formula. Okay, RJ, it is stated in the formula. Okay, just look at the formula and you can understand the second law of motion by Newton. Okay, which is acceleration is directly proportional to force and force is inversely proportional to mass. In the equation, we can actually form or state that the second law of motion by Newton as net external force is equal to, or force is equal to, mass times acceleration, because again, there is a relationship between mass and acceleration. Okay, this is the formula. Net force or external net force is equal to mass times acceleration. That explains now the second law of motion by Newton, which is the law of acceleration. Almost time. Let's finish this one. The three physical quantities involved in Newton's second law is mass, okay, system quantity, mass, mass, acceleration, and force. Okay? Mass, it could be in kilograms or grams. Acceleration, it could be in meters per second squared or centimeters per second squared. Okay? So, Newton, 1 Newton is equal to kilograms per second squared, and 1 dyne is equal to grams per centimeter per second squared. Again, 1 Newton is equal to 1 kilogram per meter per second squared, and 1 dyne is equal to grams per centimeter per second squared. Correct. Yes, RJ, correct. The SI system, in the SI system, or this is international unit, the unit force is in Newton, which is N. And Newton is that net force, which when applied is 1 kilogram mass, gives it an acceleration of 1 meters per second squared. So this is now the explanation why we have this. 1 kilogram, 1 Newton is equal to 1 kilogram per meter per second squared. Okay? The second law of motion is very useful tool in analyzing problems that involve force and motion. Because this is a law, what is the difference between a theory and a law, by the way? Theory and the law. When you say theory, it is based on facts of repeated experiment. That's theory. When you say law, it is based on natural phenomena, repeated natural phenomena, and researches. If it is natural phenomena, it is actually under law. Since the laws of motion by Newton is under a natural phenomena, this is naturally occurring, then therefore it is under the law. Okay? Let's move forward. Do you have any questions so far?
No questions, sir.
All right, let's move forward. The third law of motion by Newton is the law of interaction. Okay? This law states that when an object exerts force on another object, the second object exerts on the first a force of the same magnitude but in opposite direction, or simply for every force or action, there is an equal and opposite reaction. Or in another book, it states that in every action, there's always an equal and opposite reaction. Just like when you push the wall, okay? There is, again, in every force that you exerted on the wall also exerts a force towards you, equal force towards you. Same as when you bounce the ball, okay? A basketball. So when you bounce the ball, the floor also exerts the same force that you act or acted on in the ball. That's under the law of interaction. Okay? If you're given two interacting objects, 1 and 2, then according to the third law of motion by Newton, the law of interaction, forces acting to object 1 towards object 2 plus forces acting from object 2 towards object 1 is equal to 0. Okay? Or forces acting, are you still with me? Are you following? Are you still with me? Can you hear me?
Yes.
Okay. Forces acting from object 1 towards object 2 is equal to negative force acting from object 2 towards object 1. That's interaction. So if you're gonna exert force towards an object, that certain object also will exert force towards you. Okay? Do not be confused because these are just terminologies. Okay? These are highly observable. Okay?
Alright.
F1 to 2 is the force exerted by the first object, okay, by object 2 or towards object 2. And negative F2 to 1 is the equal and opposite force exerted by object 2 towards object 1. As simple as that. Which force may be called action and or reaction does not matter. Okay? Maybe action or F1 to 2 may be action or and negative 2 to 1 the reaction, vice versa, it can be interchanged. Okay? Again, it can be interchanged. The third law of motion always applies to two different bodies. Okay? The forces are equal in opposite directions. Okay? The third law may seem to contradict the second law. If there are always equal and opposite forces, how can there be a non-zero net force? How? That's the question there. Diba? The second law states that, okay, there is acceleration, okay, in a continuous body. If there are always equal and opposite forces, how can there be non-zero net force? Okay? It is always important to remember that the forces in each pair in the third law are opposing forces or opposite. These are opposite forces. Okay? That do act on the same object while the forces in the second law are acting on a particular object or system in a straight line. Okay? Let's take a look at. Yes. Yes, Trav. Yes, correct. Let's take a look at the difference between the three laws of motion by Newton. Number one, the first law of motion is the law of inertia, which states that an object at rest remains at rest. An object in motion remains in motion unless acted by the unbalanced force. There is a continuous movement there unless there is a force that will act on it. Unless there is an external force or the unbalanced force that will act on it. That's the first law. The second law of motion states that a body will continuously move, okay, in a straight line. Okay? Given that the mass and the acceleration is inversely proportional. Acceleration, okay, take note of the formula. Acceleration is directly proportional to force and inversely proportional to mass. So there is a relationship between the force and the mass of that certain moving body. Okay? The third law of motion will give us an idea that in every action, there's always equal or opposite reaction. And opposite reaction rather. So there are some opposing forces that is happening to that moving body or to that certain object. Like for example, if you're gonna drop a pen in your table, what will happen to the pen?
It bounces off.
It bounces off and it will, once it
Fall.
bounces off, it will
Fall and hit the ground.
fall against the ground. Okay. It will fall against the ground. After which there is no movement. Correct?
Yes.
Yes.
Okay.
Yes.
What if we
Movement
will actually
stops.
remove the ground? What will happen to the pen?
What?
What if we will remove the ground?
It will just keep falling.
It will just keep falling, correct? Because there is no force that acts on it. If it will continuously fall because of gravitational pull, therefore, it is under the second law of motion by Newton, which is acceleration. It will continuously accelerate. Okay? And also, the first law of motion by Newton will apply, the inertia. It will continuously move unless there is